Okay, so we've looked at writing geometric sequence, we've looked at writing arithmetic sequences, and we've come up with rules, ways that we could write them as a function. And all of the ones that we've done before, I just noticed a typo. That says we have definite when it should say defined. So the way that we have defined these sequences before is called an explicit rule. So we've defined them explicitly. What an explicit rule does is it gives you the nth term, so whatever term you want, as a function of the term's position number n in the sequence. This is just full of typos. There should be an apostrophe right there. So for example, like what we did yesterday, we found the rule and then we wanted to find the 10th term. So with an explicit rule, we can plug 10 into the equation and it'll tell us what the 10th term is. Sometimes it's not possible to define a function that way. And so we actually have a second way that we can write sequences, which is called defining sequences recursively. This must have auto-corrected because here it is again. Defined. So we will define sequences recursively in this section. So here's how a recursive sequence works. Recursive means kind of like a cycle. Okay, it's almost like it goes in a circle. So what we're going to do is we're going to use each term, we're going to use the term before it to find the next one. It's kind of confusing, but I'll show you. So a recursive sequence gives the beginning term, or maybe sometimes more than one term, of a sequence, and then a recursive equation that tells you how to get the nth term by using one of its previous terms. So the formulas look a little bit different, okay? But we've learned these already. Now we're just learning a different rule to use to write these. So the recursive rule for an arithmetic sequence is going to be a sub n is equal to a sub n minus 1, so that means the previous term, the one before it, plus d, where d is the common difference. The recursive equation for geometric, remember we talk about a common ratio, so it's going to be r times the previous term, where r is the common ratio. Now, these notation bits can be kind of confusing. So I want you to kind of understand how this works. Whenever we write terms, remember we say A1 is the first term, A2 is the second term, etc. So A sub n is the nth term. That means if I wanted to go one step before the nth term, I would do the n minus 1th term. So the list would look something like this: A1, A2, A3, ... and then somewhere I'm going to get to A sub n minus 1, A sub n plus 1, and then I can keep going on indefinitely after that. Here's all that means. Let's say that this middle term here was A sub 20. Well, the term before that then would be A19, and the term after that would be A21. So it's just one term before, one term after. That's all that n minus 1 and n plus 1 means. It's the symbol that we use to say the term before the one you're on versus the term after the one you're on, where a sub n is the term you're on. That's what you want right then and there. Okay? So let's look at how we use a recursive sequence. So here are a couple of examples. We want to write the first 6 terms of each sequence. Now here's what's important. That definition that we talked about said you're going to know the first term and then you get a rule. So something that is important to add to these rules here that you've got in the boxes is that you must always give a 1. Okay? So there's going to be 2 parts to your equation. You're going to say A1, the first term is blank. Then you're going to give the rule. A sub n is equal to blank. So there's always going to be at least 2 parts to a recursive sequence. Sometimes there's sequences where they might have to give you a couple of terms to start, but we'll look at that on another day. So you always have to give A1. So you'll notice here on example 1 They told us the first term. And then this recursive rule here tells us how to get the next terms. This says take the previous term and add 3 to it. So if I look at this here, okay, I'm going to write this out kind of a long way so you can see how the recursive works. So a sub 1 is equal to 2. A sub 2 is going to be equal to the previous term, so the one that comes before term 2 is going to be term 1 plus 3. That's what the rule told us up here. So that means that A2 is 5. So to get A3 is going to be equal to the previous term, which was 5 plus 3. So A3 is 8. So this is why they're called recursive, because it's sort of like this machine that keeps using the answer as the new input. So here's what happened. A1 was equal to 2, so 2 was the thing that I plugged into the equation to get the next term. Then I got 5, and 5 was what I plugged in to get the next term. So now if I want to do A4, I'm going to use 8, which was the previous answer, plus 3 to get my new term, which is 11. And we keep doing that and doing that over and over again. It's called recursive because it uses the answer to get to the next thing. So it's like we've talked about these little function machines, right? So something like this. So I plug a number in, and then I get a number out, but what a recursive function does is it takes this thing that you get out and plops it back into the machine to run it through again, okay? And that's really the idea of what a recursive function does. It's kind of a cycle. So that's the fourth term. So the fifth term then would be to add 3 more to that, and the sixth term would then be to add 3 more to that. So if we write out our list, A1 was 2, A2 was 5, A3 was 8, A4 was 11, the next one would be 14, and the sixth term would be 17. This is arithmetic. Hopefully you can see that because we are just adding 3 every single time. And so on and so on. So it's a rule that we're familiar with. We've already seen it before. It's just a different way of writing the rule. So number 2 says the first term is 1, and to get the next term, you multiply the previous term by 3. That's what that rule says. So if we look at this kind of the same way here, A1 is going to be 1. A2 is going to do 3 times the previous term, n minus 1, which in this case was 1, so we get 3. I'll just do one more so you can see how the machine kind of works, and then we'll list them out. So A3 is going to be equal to 3 times this one here, so that's 3, which is going to be 9. So we have 1, 3, 9. You see the pattern here is to multiply by 3, so I'll get 27, 81, and then 243. And so those are the first 6 terms of the sequence, okay? So the last thing that we're going to look at here is how to write a recursive rule. And these are actually really easy to write, okay? So the first thing that we have to decide is it arithmetic or is it geometric? And I've scrolled off the page, but you have the box up above you that says for arithmetic, the rule is going to be like this. This is what I told you a second ago. We have to say what A1 is equal to, and then A sub n is going to be A sub n minus 1 plus D. If it's geometric, we have to tell what A1 is, And then the rule for a sub n is going to be r times a sub n minus 1. Here's the parts that are never going to change. This is going to stay a sub n. This is going to stay a sub 1. Same thing over here. So the only places that we are going to substitute values is in this case for d and in this case for r. And then we have to tell what a1 is equal to. That's the only information you have to know. We don't have to do any other work or any other steps. So these rules are actually easier to write than the other ones. So if we look at number 3, the first thing we have to decide is if it's arithmetic or geometric. And to do that, we have to think about what the pattern is. And so we want to see, are we adding or subtracting the same thing every time? Or are we multiplying and dividing every time? Well, for this one, we are adding 12. Plus 12, plus 12, plus 12, plus 12. That means that D is equal to 12. So here's how easy it is to write these rules. First, we must give A1, and that's always your first term. So A1 is equal to negative 30. Then, remember the highlighted stuff stays the same. So we say A sub n is equal to A sub n minus 1 plus D. Well, D is positive 12, so that's plus 12. If it were negative, then we would say minus 12. But guys, that's it. That is the whole rule. You are done. Okay? So if we look at number 4, you can look and figure out the pattern. This one, hopefully you notice, is not adding or subtracting. So that means that this one is geometric. And so again, the first one we said was arithmetic. That's important to decide. So this one here is geometric. And so the pattern here is that we're dividing by 5, but remember that means that we're multiplying by 1/5. So times 1/5 times 1/5, on and on and on, dot, dot, dot. So here's our rule. We're going to use the second one for geometric this time. So again, we have to give A1. So the first term is 500. And then the nth term is going to be R. We said that's 1/5 times A to the n minus 1. Finished. That is all there is to it. Okay? So we're going to stop there for today, and this is what I want you to practice on your own before I come back tomorrow. So I will see you guys then.